Hello viewers, welcome to my channel. I'm Hashim Ali Khan. So far 9 problems I have completed on transportation. In this video, 10th problem I'm going to explain. So you have seen in every problem 1 or 2 new points we are coming across. In this problem, the problem will be degeneracy problem, where the number of allocations may not be equal to m plus n minus 1, and also the problem is unbalanced. So without balancing, we cannot find out the IBFS. So before starting IBFS, we have to make the problem balanced one. Balanced problem means the total of supply and the total of demand must be equal. The row totals and column totals must be equal. So before starting the 10th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep it ready. Take the screenshot of the points which I have written on the board, then I'll explain every point in detail. Now, see the problem number 10. XYZ Iron and Steel Company has 3 open hearth furnaces and 5 rolling mills. Transportation cost rupees per quintal for shipping steel from furnaces to rolling mills are shown in the following table. Furnaces are F1, F2, F3, 3 rows, and mills are M1, M2, M3, M4, M5, 5 mills. Mills are the destination and furnaces are the origin. Now the capacity of the furnaces are 8, 12, 14. If you add up, it will become 34. So 34 quintal is the supply. From 3 furnaces. And the demand at the mills are 4, 4, 6, 8, 8. If you add up, you are getting 30. That means the demand at mills is 30. Whereas supply from the furnaces are 34. The problem is unbalanced. To make it balanced, we have to open one more mill, dummy mill, whose requirement is 4 quintals and the unit cost will be 0. Then again, we are given the cost per unit from F1 to M1, 4, from F1 to M2, 2, from F1 to M3, 3. All transportation costs are given. That is the problem. Now, total requirement at the mills, 30. Total capacity from the furnaces, 34. The problem is unbalanced. To make it balanced, we open a dummy column, dummy mill, with requirement of 4 units and cost will be 0. So this is the VAM table. Finding an IBFS by VAM. Furnaces, mills. Furnaces F1, F2, M3. Mills are M1, M2, M3, M4, M5 and dummy. The requirement of dummy is 4 units. This is not given in the problem. We have opened the dummy column with a requirement of 4. Now if you add up 4 plus 4 plus 6 plus 8 plus 8 plus 4, you will get 34. Now it is balanced. So 8 plus 12 plus 14, 34. Row total, column total, 34. Balanced. Now all other costs, 4, 5, 6, 2, 4, 5, all the costs are given in the problem. I have taken it on the upper right corner because allocations we have to give in the middle, right? Now, penalties. So I have opened 1, 2, 3, 4, 5 penalties. We may get in 4 penalties, 5 penalties, or sometimes 6 penalties or so, depending on the problem. Here we have 3 rows and 6 columns. 3 rows and 6 columns, a huge, big problem. That's why I have taken 5 penalties. Penalty is the difference between the smallest cost and the next smallest cost in every row and every column. The first row, 4, 2s, 3, 2, 6, 0. The minimum is 0. The next minimum is 2. 2 minus 0 is 2. Next, 0 to 1. So 1 minus 0, 1. Minimum 0. Next minimum is 3. So 3 minus 0 is 3. Row penalty we have calculated. Now I am coming to the column penalty. The first column, 4, 5, 6. Minimum is 4. Next minimum 5. 5 minus 4, 1 is the penalty. Then 2 to 4, that means 2 is the penalty. Then 3 to 4, 1 is the penalty. Here 2 minus 2, 0 penalty. Here 1, 3. So 3 minus 1, 2 is the penalty. Here 0, 0 minus 0 is 0. Now we got the first penalty in rows and columns. Find out the highest penalty. The penalties are 2, 1, 3, 0, 2, 0, 1, 2, 1. Highest penalty is 3, the round of the 3. Where we are getting the 3 highest penalty in the row F3. So what is the minimum cost in this row? 0 is the minimum cost. So we allocate in this cell. The row total 14, column total 4, right? So we allocate 4 units here. This will become 0. 14 minus 4 is 10. Whichever row or column becomes 0, block that row or column. Here column has become 0. So block the column. This is the blocking of this dummy column. That's all. First penalty completed. Now I am coming to the second penalty. Second. Minimum is 2. Next minimum also 2. So 2 minus 2, 0. Here minimum is 1. Next minimum 2. 2 minus 1, 1. Minimum is 3. Next minimum 4. So 4 minus 3, 1. Now column wise. Minimum is 4. Next minimum 5, 1. Minimum 2. Next minimum 4. So 2. Here minimum is 3. Next minimum 4. 4 minus 3, 1. Minimum 2. 2 minus 2, 0. Minimum 1. Next minimum 3. 3 minus 1, 2. This is dash because exhausted. Or. Now what is the highest penalty? 0, 1, 1, 2, 1, 2. So 2 is occurring 2 times. Whenever there is a tie in penalty, compare the cost. Wherever we are having less cost, there will apply. So here if we select this 2, what is the minimum cost? 2. If we select this 2, minimum cost is 2. If we select this 2, minimum cost is 1. So 1 is less than 2. So we round off this 2. And we allocate in this cell 1. So row total 12, column total 8. Whichever is less. 8 is less. So 8 minus 8, 0. 12 minus 8, 4. So column has become 0. Block the column. Now I am coming to the third penalty. Penalty number 3. Minimum 2. Next minimum 2. So 2 minus 2, 0. Here minimum is 2. Next minimum 4. 4 minus 2 is 2. Here minimum is 4. Next minimum 5. 5 minus 4, 1. Row penalty completed. Column penalty 5 minus 4, 1. Here 4 minus 2, 2. Here 4 minus 3 is 1. Here 2 minus 2, 0. This is completely exhausted, dash, dash. Now what is the highest penalty? Here 2, 1, then 1, 2. 2 is the highest penalty, but again tie. So we compare the cost. If we select this 2, the minimum cost is 2. If we select this 2, minimum cost is 2. That means cost is also time. Then we compare the allocations, where we can give the more allocations that we will select. If we select this 2, how much allocations we can give in this cell? Row total 8, column total 4. So approximately 4 allocations we can give. If we select this 2, this cell, the column total 8, row total 4. So 4 allocations. That means allocations are also time. So our cost is time, the penalty is time, cost is time, and allocations are also time. Then we can take arbitrarily any 2. So I will select any one of the 2. Suppose I have selected this 2. This 2 I have selected. So what is the minimum cost here? This 2. How much allocations? 4 allocations I can give. 4 minus 4, 0. 8 minus 4 is 4. So row has become 0. I will block this row. This row is blocked. That's all. 3 penalties completed. Now I am coming to the 4th penalty. 2 minus 2, 0. Here blocked, dash. Here 5 minus 4 is 1. Now I will come to the column. First column, 6 minus 4 is 2. Here 5 minus 2 is 3. 5 minus 2 is 3. Here 4 minus 3 is 1. Here 7 minus 2 is 5. Then here dash, dash, 0, 0, so dash, blocked. Now in this fourth penalty, what is the highest penalty? 0, 1, then I'll come here, 2, 3, 1, 5. So you can see 5 is the highest penalty. I'll round off this 5. What is the minimum cost in this column? 2 is the minimum cost. So I will allocate here row total 8, column total 4. So I will allocate 4 here. This 4 will become 0. 8 minus 4 will remain 4. This column is blocked. That's all. One more penalty we need. Fifth penalty. Here minimum 2. Next minimum 3. 3 minus 2. 1. Here it is blocked completely. Dash. Then here it is 5 minus 4. 1. That's all. Now column wise. 6 minus 4. 2. Here 5 minus 2. 7. 5 minus 2 is 7. Here it is 4 minus 3, 1. Here dash, dash, dash. The highest penalty is 1, 1, then last one 2, 7. 7 is the highest penalty, round off. What is the lowest cost in this total? 2. Now we allocate in this 2 cell. Row total 4, column total 4. So this 4 if I allocate, this 4 minus 4 will become 0 and this 4 will become 0. That's all. Now if any row or column have any unoccupied cell, then we have to cancel it. This 0 is cancelled now. This one, this is blocked. This has become 0, so column is blocked. This has become 0, so row is blocked. That's all. Now, if any row or column have only one unoccupied cell, then we can take the balancing figure. In the first column, you can see only one unoccupied cell is there. And the column total remaining is 4. So, I will allot 4 here. This will become 0. Here, 10 minus 4 remains 6. Right? Now, only one unoccupied cell is left. The row total is 6, column total is 6. If I allocate 6 here, this will become 0 and this also will become 0. Now you can see all the cells are either allocated or occupied. No blank cell is there. And all the supply and demand all are 0, 0, 0, 0. Here 0, all zeros. That means correctly we have made the allocations. The next step, we have to see whether it is degeneracy or non-degeneracy. If the number of allocations are equal to m plus n minus 1, then the problem is feasible. Non-degenerate, we can proceed ahead. But first time we are coming across where the number of allocations are not equal to m plus n minus 1. Here number of allocations are 1, 2, 3, 4, 5, 6, 7. Totally 7 allocations we have given. So here I am writing number of allocations are 7. But m plus n minus 1. M stands for number of rows, n stands for number of columns. 3 rows and 6 columns. 1, 2, 3, 4, 5, 6. So 3 rows plus 6 columns minus 1. It comes to 8. This is the new point. First time we are coming across. Number of allocations are not equal to m plus n minus 1. Problem is not feasible or degenerate problem, or we can say degeneracy problem. In that case, we cannot proceed ahead to find out the optimum solution. We have to overcome this degeneracy, make both equal. That means the number of allocations must be 8 when m plus n minus 1 is 8. Both must be equal. So how to make it equal? We apply a valueless or quantity-less quantity, that is epsilon. We apply epsilon. What is epsilon? It's the smallest quantity, approximately equal to negligible. For the sake of theory, we assume that epsilon is a quantity. But in reality, this epsilon does not have any weight, weightless quantity. Weightless quantity. So we have to apply epsilon in any of the unoccupied cell. There we apply epsilon. So we treat epsilon as also one of the allocations. In that case, 7 allocations will become 8 allocations. One extra allocation we are giving. So where to give? Any one of the unoccupied cell. But that cell should be independent. That means no loop should be formed in that cell. From that cell where we are giving epsilon. So here, since the number of allocations are less than m plus n minus 1, so the IBFS is degenerate. Therefore, a quantity epsilon, this is a symbol for epsilon, is added to one of the empty cell. Suppose I am allotting to 1, 1. 1, 1 means first row, first column. This is the first row, first column. This is a blank column, unoccupied, right? The other occupied cells I will take down 4. This is 4. Then again 4. Here 4. Then 4, 8. This is 4 and this is 8. Then here 4. Next one is 6. Last one is 4. These are the allocations already we got in IBFS. Same allocations. One more allocation we are giving, that is epsilon, in any one of the unoccupied cells. So we can give any unoccupied cell, but it should be independent. There should not be any loop formed. So I have selected this one. Here I am giving epsilon. Now I will make this also as an occupied cell. But remember, it is weightless quantity. There is no weight for epsilon. Now if you add up epsilon plus 4, you will get 4 only. Similarly, epsilon plus 4 is nothing but 8 only. Right? Now the allocations will become 1, 2, 3, 4, 5, 6, 7, 8. 8 allocations. And 8, m plus n minus 1 is 8. Now it is ready for finding out the optimum solution. That is the new point. Now, to find out the optimum solution, we need ui and vj values. ui, u1, u2, u3, right? And vj, v1, v2, v3, v4, v5, v6. Now we need the values of ui and vj. Remember, any one of the u value we can take it as 0. So normally we select any row. Any row you can select. Either u1 you can take 0 or u2 or u3. Suppose I have arbitrarily selected u3 is equal to 0. Here u3 I have taken as 0. The other values of ui and vj can be found by using the following formula equation. Cij is equal to ui plus vj for occupied cells. For occupied cells. So here I have taken u3 is equal to 0. Automatically we can get 4. This occupied cell. So what is the Cij here? 6. So I can take 6 here. Here 4. So here 0. 3 values directly we got. Suppose if you want to calculate C31. C31 is this cell. How you got 4? C31 is equal to U31 plus V1. U3 plus V1. So how much is C31? 6. Is equal to U30 plus V1. So we can say V1 is equal to 6. One value we got. Similarly, 3, 3. 3, 3. So C33 is equal to U3 plus V3. How much is C33 here? 4. 4 is equal to 0 plus V3. So V3 is equal to 4. You can see here V3 is equal to 4. Similarly, C36. C36 is equal to U3 plus V6. How much is C36? 0 is equal to U3 is 0 plus V6. So V6 is equal to 0. 3 values we got it. Now we need C11, this one. C11 is equal to U1 plus V1. How much is C11 here? 4 is equal to U1 we don't have. But V1 we have 6. That means if we take this plus 6 to minus 6, so 4 minus 6 is minus 2. So U1 is equal to minus 2. Because I am taking 6 to LHS, so 4 minus 6 is minus 2. So U1 is minus 2. One value we got. Now C12, this cell. C12 is equal to U1 plus V2. How much is C12 here? 2. 2 is equal to U1. U1 how much? Minus 2 plus V2. Then V2 is equal to this minus 2, if I take it to the LHS, 2 plus 2, 4. So V2 is equal to 4. We got it. Now we'll take this cell. Which one? This cell. What is the location? 1, 4. C14 is equal to U1 plus V4. What is the value C14? 2. 2 is equal to U1 minus 2 plus V4. Then V4 is equal to minus 2, if I take it to LHS, 2 plus 2, 4. So V4 we got 4, right? Then C24, this one, C24, this one. So C24 is U2 plus V4. So C24 how much? 2. 2 is equal to U2 plus V4 how much? 4. So if I take the 4 to LHS, 2 minus 4 is minus 2. So U2 is equal to minus 2. U2 we got minus 2. Lastly 25, C25, this cell. What is the location? 25. So C25 is equal to U2 plus V5. How much is the C25 here? 1. 1 is equal to U2. U2 is minus 2 plus V5. Then V5 is equal to minus 2, if I take it to LHS, 1 plus 2 is 3. So V5 is 3. That's all. So we got all the values of Ui and Vj. All the values. U1, U2, U3, V1, V2, V3, V4, V5. All V6. All the values we got. Now opportunity cost for unoccupied cells, that is denoted as delta Ij is equal to Cij minus Ui plus Vj. Without writing all these things directly from the table we can calculate. Otherwise, if you are not sure, if you are confused in calculating the value, make this equation. For example, the first unoccupied cell is this one, 1, 3. So delta 1, 3. Delta 1, 3 is equal to C13. How much is C13? 3. That is equal to 3 minus U1 plus V3. U1 is minus 2 plus V3 is 4. So 4 minus 2 is 2. In the bracket you will get 2. So 3 minus 2 you will get 1. This one is the opportunity cost I am writing on the left side. This is the actual cost and this is the opportunity cost. Now I am coming to F1 M5. So delta 15. So delta 15 is equal to C15. How much is C15? 6. So 6 minus U1 plus V5. U1 is minus 2 plus V5 is 3. So 3 minus 2 is 1. So 6 minus 1 is 5. So we got 5 opportunity cost. Now this cell 16. Delta 16 is equal to C16. C16 is 0. Minus 1. U1 is minus 2 plus V6. V6 is 0. So minus 2 plus 0 is minus 2. So minus into minus will become plus. So 0 plus 2 is 2. So here 2 opportunity cost, right? Here you can see here 5 minus 6 minus 2. 6 minus 2 is 4. So 5 minus 4, 1. Here how much? 4. 4 minus 2 is 2. So 4 minus 2 is 2. Or else you can write like this also. Here 4 minus 2 is 2. 5 minus 2 is 3. Here 0 minus 2 is minus 2. So 0 minus minus 2 will become plus 2. Right? Here 4 plus 0 is 4. 5 minus 4, 1. Here 4 plus 0 is 4. 7 minus 4 is 3. Here 3 plus 0 is 3. So 3 minus 3, 0. That's all. Whether you apply in this formula or directly if you observe and calculate, you will get the same answer. Simply add up Ui value and Vj value and deduct that sum from the Cij value. Cij minus Ui plus Vj. That's it. Fortunately, we got all the opportunity costs are positive. See here, 1, 5, 2, here 1, 2, then 2, then 1, 3, 0. So all the opportunity costs are positive. So we reached the optimum solution. So optimum, all the opportunity costs are positive. So we reach the optimum solution, the optimum assignment, and its total minimum cost will be as follows. Now we take the allocations. Here F1 to M1. F1 to M1. How many units? Epsilon, and unit cost 4. Second, F1 M2. F1 M2. 4 2. 4 units, 2 rupees. F1 M4. F1 M4. 4 2. 4 units, 2 rupees. Then F2 M4. F2 M4. How much? 4 2. 4 units, 2 rupees. Then F2 M5. F2 M5. F2 M5. 8 1. 8 units, 1 rupee. Then F3 M1. F3 M1. 4 6. 4 units, 6 rupees. Then F3 M3. F3 M3. 6 units, 4 rupees. 6 4. Then F3 dummy. F3 dummy, that is 40. That's all. Now simply you multiply epsilon into 4 is 0, because epsilon is 0 only. Then 4 into 2, 4 2 is 8, 4 2 is 8, 4 2 is 8, 8 1 is 8, 6 4 is 24, 6 4 is 24, 4 into 0, 0. That's all. Now simply you have to find out the total. That is 8 plus 8 plus 8. Then plus 8, how many times? 4 times. Plus 8, 32. 4 times 8 plus 24 plus 24, it comes to 80. The total transportation cost is 80. That's all. So in this problem, problem number 10, 2 more points. The first point is regarding unbalanced problem, and secondly, epsilon. When number of allocations are not equal to m plus n minus 1, we allocate epsilon in any one of the unoccupied cell where we cannot be able to make a loop, independent cell. Then we treat that as an occupied cell. But in reality, that epsilon is a weightless quantity. Even if we apply epsilon, the total will remain same. After that, as usual, we calculate UI, Vj value and opportunity cost. All the opportunity costs are positive. We reach the optimum solution and the total transportation cost we got. So we have completed 10 problems. So if you want perfect knowledge, watch all the videos twice, thrice and make a note of it. Always maintain notes, whatever I am explaining. OR is comparatively a tough subject. Until and unless you practice yourself, it will be difficult to get a command. So my suggestion, if you want perfect knowledge, watch all the videos. Go to the playlist of my channel, select the subject operational research, select the videos of this transportation problem. Be perfect. Get a good command, confidence. Then only you can write excellently in your exams. Inshallah, we'll continue the next problem, problem number 11 in the next video. If you are satisfied, give a like to the video, share my channel, subscribe if you have not yet subscribed, and buy the super thanks which is given below my video. Inshallah, we'll continue our next problem in the next video.